Hello everyone, let us see about transient analysis in this video today. Before that, we must know what is transient response. Transient response of an electrical device can be understood by using the electrical device with a switch. Switch can be opened or closed. In order to connect to supply to device or disconnect supply from the device, we use a switch. The study of switching condition in a circuit is called transient analysis. You must know that the state of circuit from instant of switching, that you can see it from the diagram, the instant of switching to the attainment of steady state is called transient state, which means at the time of 0 we are going to switch the circuit and it can extend till time is equal to infinity. The time duration from the instant of switching till it reaches the steady state is called transient period. It is said as transient period because we are going to calculate the time duration. The response of the circuit, that is the current and the voltage of the circuit element during the transient period, is called the transient response. Any electrical circuit will have mainly three elements. They are resistor, inductor and capacitor. Inductor and capacitor are energy storage devices and hence they may have stored energy which is prior to switching instant. That is, if we use an inductor or capacitor which is being charged already in a circuit, we must consider that extra voltage in a circuit. Hence, there will be a conduction of the circuit even if there is no source present in the circuit. Hence, we can conclude that the response of the circuit due to stored energy alone, that is without any external source, is called natural response or source-free response. The response of the circuit due to an external source is called as forced response. So that we can get the response of a circuit due to natural response one and the forced response as other. Now let us see about the switching condition. In order to study the response with respect to time, the switching instant is taken as time origin, that is t equal to 0. The time origin is taken as t equal to 0 and t is equal to 0 minus, which means it denotes the time before switching. The time t equal to 0 plus indicates the time which is taken after switching. So we must consider time as 0 minus, 0 and 0 plus. Now let us see the response of current and voltage in resistance, inductance and capacitance. The resistance will allow the sudden change in current and voltage. That is, the current before switching will not be equal to the current after switching. In the same way, the voltage in the resistance before switching will not be equal to the voltage after switching. That is, VR of 0 minus will not be equal to VR of 0 plus. If we consider an inductor, it will allow the sudden change in the current, but it will not allow the change in the voltage. That is why the current before switching is equal to current after switching and the voltage before switching will not be equal to after switching. That is, the value of voltage varies after switching. Now if we analyze the capacitor will allow sudden change in the current, but it will not allow sudden change in the voltage. That is why the current before switching will not be equal to after switching and voltage in the capacitor will be same as before switching and after switching. Till now we have seen how to get the transient response of a circuit. Now let us see how to analyze a circuit and how to get the calculations so that it is easier for us to calculate the responses of the circuit. Let us see about transient analysis by using Laplace transform. In order to solve a circuit using Laplace transform technique, the given circuit is first transformed into a S-domain circuit and then source and parameters are replaced by its S-domain equivalents. So now let us see the S-domain representation of RLC parameters. We must understand that we are using RLC in a circuit. So we must use only the AC source to give the supply. So we should consider all the elements parameters. So if you take the resistance R, we will be writing it as small I, r and small v, because we are taking it in the time domain. If we are going to convert it into s domain, it is small I can be converted to capital I of s, small v can be converted into capital V of s. Let us consider the inductor. The inductor L, for which the current is given in time domain as small I and voltage is given as small v. And if you are converting it into S domain, it is given as capital I of S and capital V of S. The inductor should be written with a S along with it. So S L will be the inductor value. If the inductor is already being charged and it has some charge initially, the inductor with initial current will be given as I of 0 minus. You have a current, no? That should be written as I of 0 minus. So you must also include that I of 0 minus in time domain. When it is converted into S domain, it should be written as L I of 0. If there is no charge mentioned for I of 0 minus, then you can directly substitute it as 0. We will see it in the problem. If we consider the capacitor, the time domain value is again small I and small v. But if you convert the capacitor value, it must be converted as 1 by SC and capital I of S and capital V of S. If the capacitor is being charged initially and that is being used in the circuit, then we must include a V of 0 or V0 in the circuit. So the voltage will be mentioned as V0 and in S domain it must be converted as V0 by S. By considering all these parameters for a resistor, inductor and a capacitor, the current and voltage in time domain can be converted into S domain by using Laplace transform, and again it is converted to time domain by using inverse Laplace transform. Laplace transform is considered only for the calculation purpose, and it will be very easier to calculate the values for the responses which we obtain from the circuit. And hence we can conclude that we have seen about how to analyze a circuit and its parameters for resistor, inductor and capacitor, and how we can analyze the circuit by using time domain to S domain using Laplace transform in this video. In the next video, we shall see the problems related to this transient analysis and how to obtain the responses, that is current and the voltages.